Hi, this is Math 8, Unit 5, Lesson 14, Finding the Cylinder Dimensions. Today we're going to be talking about the dimensions of cylinders. And so, here we go. So first of all, we have a picture of a cylinder here, and it says, what is the possible volume for the cylinder if the diameter is 8 centimeters? And explain what your reasoning is going to be. So as we talked about this in class, one of the things you may have talked about was that if the diameter for an object or a circle is going to be 8, then we know that the radius is going to be half of that, which is going to be 4. Now we think back to maybe what we learned before about circles. We know that when we take the circle, we can find the area of a circle by taking the radius, and the area of a circle is going to be pi times the radius squared. And so we know that to be true about the area of the circle, or in this case, this would be the area of the base. And when we're talking about volumes and shapes like this, three-dimensional shapes, we talk about having the base of an object, find the area of the base, and then multiplying that by the height of that object. So in our case here, if I knew that the diameter was 8 and the radius then would be 4, if I did pi times r squared, and I multiplied the area of the base times the height, and I substitute some values in here, I could do pi there, and then 4 squared times the height, and 4 squared is going to be 16, so I can rewrite that as 16 pi times h. You could substitute a value in there for pi if you wanted to, however you want to do that, or you could leave it in terms of pi. It just depends on how you wanted to have a final answer there. But if the height happened to be 1, for example, let's say it was 1 centimeter tall, so if that height happened to be 1, we could take that value of 1 and plug it in there, and we could say that the volume would be equal to 16 pi, and then maybe it was 1 centimeter, so 16 pi centimeters cubed, if that happened to be a height of 1 centimeter. And again, we're just making up a number there. It doesn't tell you that it's 1. But if the diameter was 8 and said that was 1, that's what you could say. Now just looking at it from here, you might want to say more that the height of this one is probably more closer to 8, because that seems to be about the same length. So it might be better to multiply by 8 to get an answer. But for the sake of what we're doing, that works just fine. When we move down to our next activity, what you did today in class is it said, what is the dimension? It says the volume V of a cylinder with radius r is given by the formula V equals pi r squared h. So that's our formula that we would use to find the volume of an object, or the volume of a cylinder to be precise. So it's pi times the radius squared times the height, which again, this is the area of the base of a circle times the height right there. The volume of the cylinder with radius 5 units is 50 pi. So that's the volume is 50 pi. This statement is true. 50 pi, which is the volume, equals 5 squared pi r. So this is going to be the radius squared, and that's the pi, and that's the h. Okay? What does the height of the cylinder have to be, and explain how you know? So what they're giving us here is they're saying, well, here's your radius, which is 5, and we're going to square it. That's our pi, and then we also have this unknown value of h. All right, it's kind of what's missing piece there. So if we know this is true, again, this is a true statement, and this 50 pi is equal to whatever this is going to be there. If that's a true statement, then the way we would know would be by kind of working out the process on the right side to match what we have on the left side. So I have, first of all, 5 squared pi times h. I could find out what 5 squared is, which is going to be 5 times 5, which is equal to 25 pi times h. And then I could either use some kind of algebra to move things around, or I can just use some logic here a little bit too. Notice they both have a pi on each side. So I can almost start to just mentally or visually ignore the pi, right? It's going to go away. And then what left on this side is I have a 50 over here, and that's going to be equal to 25 times some height. And so again, using some logic, what number times 25 can get you to 50? right? That's all they're asking you to do. Or if you want to do algebra, you could divide both sides by 25 in order to find out what h is going to be. And either way, 25 times 2 is what you get here. It's going to be equal to 50. So the height of this object is going to be 2. In our case here, we just call it 2 units. That's our height. And so you can get that by using some logic or using some algebra to find out that missing variable. This is going to happen a lot in the next few lessons, okay, where we're going to use the formula that we're provided with, and then we're going to find for various parts of that formula. Either we're going to try to figure out the radius, or the height, or the volume. Just depends on what it asks you to do. So don't get locked into thinking every problem about volume is going to be to use those values to find the volume. Sometimes they're going to give you the volume and ask you to find the other missing values. Let's take a look at the next side. Number 2, I should say. In this one, it says the volume of this cylinder with height 4 units is 36 pi cubic units. So that's our volume. So the volume is going to be 36 pi. So this is our V right here. All right, this statement is true. So again, we have radius squared pi 4. So in this case, they gave us the height, right? That's the height, but they did not give us the radius. So we can solve this a couple of ways. All right, here's 36 pi is equal to some radius squared times pi times 4. All right, so again, this is like you had before in the past with some hangers, right, type of thing. If I have something on both sides, I can essentially eliminate that. So I can eliminate the pi's on both sides just to work with the regular numbers. So I have 36 over here equals r squared times 4. If I wanted to use some algebra, I could divide both sides by 4. So 36 divided by 4 is 9, and that equals r squared. And so then I ask myself, what number can I square to get to 9? That's what I think to myself, right? Another way of doing it is I can get rid of the square, which is not part of your lesson today, but I could take the square root of both sides. That will eliminate the square, and the square root of 9 is 3, and so the radius is going to be 3. It's probably, in this case here, just easier to think about what number times itself can get you 9. And that's 3 times 3, so our radius is going to be 3. All right, and that's the idea. So the radius is going to be 3, and the reason we know that is we just worked through kind of logically what it had to be. All right, so suppose a cylinder has a volume of 36 pi cubic inches. So there's our volume. But it is not the same cylinder as the one you found earlier, right? We did one a second ago where it was 36 pi. So what are some possibilities for the dimensions of the cylinder? How many different cylinders can you find that have the volume of 36 pi cubic inches? The idea being, okay, well, we already did one where 36 pi was what we had when the radius was 3 squared times pi times the height. So, the height, sorry, was 4. Apologize. So when we had a height of 4, so that's our radius and our height right there. That's one we just did a second ago in the previous problem. Are there other ones that could work if you know it's going to be 36 pi? Are there other values of r that can be squared times a pi times an h that can get you to 36? Are there other things that you could do there? And in our case, there probably are, all right? And so one thing that I did, and this was a little bit more complicated, is I thought, well, I still need to get to a place where this is going to be 36. So I need an r squared value times an h to equal 36. So one thing you could think about doing is I went ahead and thought about 9. I used 9. Why 9? Well, I did 9 squared. And when I do a 9 squared, I know it's going to be 81. It's pretty large, right? So if I did 9 squared and made this equal to 36, and that's 81, h equals 36. If I was to divide both sides by 36, or by 81, sorry, by 81, you'd think that's kind of a crazy thing, but it does work out. I could put h there, and when I think about this one here, I think, well, 9 goes into 36 4 times, and 9 goes in 81 9 times. So if I use that as my height and 9 as my radius, it actually would work out. Think of it this way. This is 9 squared times the height of 4/9 equals 36, right? So let's write this out more of an expanded way. 9 squared is the same as 9 times 9, and I also have a times the 4 right there, all over the 9 right there, equals 36, right? And so a 9 over 9 can be reduced to 1, and so what am I left with? 9 times 4 is 36. So a long way of doing that, but it does work out, and it shows there are other ways you can do that. Could you find some other ones? You possibly could. I'm going to leave it there for now. Let's look at activity number 3. For activity 3, it's called cylinders with unknown dimensions. And so we have like cylinder here, and we have a diameter, we have a radius, we have height. And then we're going to take the information that we use in the table and fill in for the missing pieces that we're not provided with. All right, so we know that our diameter is, again, the distance all the way across that circle. The radius is going to be half of the diameter. The area of the base is pi r squared. The height is just our height. And the volume is what happens when you put all that together, right? That's going to be pi r squared times the height there. So let's take a look here. Let's go across. If the radius of a circle is 3, and I want to go to the diameter, then I'm going to multiply by 2. I'm going to double it. So 3 times 2 is 6. In terms of the area is going to be pi times the radius squared. Well, in our case here, that's pi times 3 squared, which is 9 pi. Now, since our height is going to be 5, then the volume is going to be those two things multiplied together to get the volume. So we end up with 45 pi. And then you're going to do the same thing for the other problems. Let me do a couple more of these, okay? So here we go. We have the diameter is 12, so the radius is half of that. Half of 12 is 6. Okay, we know we're going to do pi r squared. So pi times 6 squared for the area of the base. 6 squared is going to be 36 pi. All right, and now I know that my volume is going to be 108 pi. So 36 times some number, some height value right here, 36 times the height is going to equal 108, right? So if I wanted to get the h by itself, I would divide this side by 36 pi, right? Divide that over there to find out what h is going to be. And 108 pi divided by 36 pi is equal to 3. So our height is going to be 3. I don't remember what the pi's that go away. So 3 times 36 is 108. This way, we have gotta go this direction. We know that the volume is 99, and we have a height of 11. Okay, so I know that my base is going to be pi. We know that much, right? I'm going to be multiplying the height times the area of the base, and I need to get to 99. So what number times 11 can get you to 99? Again, you could divide 99 divided by 11, and you'd find that that's going to be 9. Now that's the area of the base is 9 pi, because 9 times 11 is 99. Can I use this to find out the radius? I sure can. This 9 comes from what? It comes from r squared, the radius squared. So what number times itself gets you to 9? Had that a second ago. That's going to be 3. And then the diameter is going to be doubling the radius, 3 times 2, which is going to be 6. All right, so that's that one. So those are those 3 there. We can go back across this way again. 8, going to cut it in half to find a radius of 4. We're going to do pi times the radius squared. Pi radius squared is going to be equal to 16 pi. I'm going to do 16 times some height in order to get to 16 pi. So 16 times what gets you 16? That's going to be 1. So our height will be 1 right there. Alrighty. Okay, coming back the other way, this way, 16 pi, and we're going to do 100 times something pi gets you to 16. So again, if this was like an equal sign, and that was like our radius squared. We can just call it x for now. All right, and I divide everything over here. If I divide this by 100 pi, I really can't reduce that too well. So I'm going to leave it as 16 over 100 pi is the area of the base. It's not a very nice area of the base, but I'm doing that on purpose. That's because I want to think about what two numbers can multiply together to get me 16 over 100. Okay, so for the 16, so when I think about the 16, that's going to be 4 times 4, and the 100 would be a 10 times a 10. Meaning in this case, our radius, because radius squared, would just be 4 over 10, or 4/10. Now, if that's the radius, then I want to double that to get to the diameter. So think about it being times 2 times 2, or times 2, not 2 over 2, that's 1. So I multiply by 2 to get the diameter. I go 4 times 2 is 8, and then I have 10 on the bottom. So my diameter is going to be 8/10 right there. Okay, so a little more complicated there when you're dealing with a fraction, but it does work out okay. All right, on the next one here, we have our radius. So if I want to double it to get the diameter, 10 times 2 is 20. To find our area of the base, that's going to be pi times the radius squared, so it's going to be 100 pi. And I'm going to multiply that by some height to end up with 20. Again, I could divide by 100 pi to find out my height, and 20 divided by 100 is 1/5. So you get some fraction answers here, and that's okay, just a little different, all right? So don't get too nervous about that. So our height is going to be 1/5. Okay, on this one, 20 dividing in half gets you to 10. We already know that's going to be equal to 100 pi because we just did that. But now 100 pi times something is going to be equal to, in this case, 314. Notice that in this case here, there's no pi value, is there? So it's been multiplied out. We know that pi is 3.14, right? So 3.14 is what pi is, which is going to make h equal to 1. And the reason it's equal to 1 is that 100 times 3.14 is going to equal 314. Again, I could divide this by 100 pi, and I'd end up with 3.14, end up with 1, sorry. Okay, in this one here, here's a pi and an h and a r. Why is this the h? Because that one's squared, so that's going to be the r. So what's our height? Our height is b. What is the area of our base? That's going to be a squared. A squared. What's the area of the radius? Or what's the radius? The radius is just that. Okay, I should say it's a squared pi. Okay, the radius is just the a. And then what's the diameter? Again, I'm multiplying by 2, so it's going to be 2a right there. And that's the idea. So a little bit cumbersome, just a lot of problems to solve there, but very, very good practice for you. And hopefully you had those right in class. I'm just kind of reviewing them more than anything else. So as our summary today, we have here our formula or equation for the volume of a cylinder. The volume of a cylinder is the radius squared and height times pi. So we say that the volume depends on the radius and the height. And if we know the radius and the height, we can find the volume. It's also true that if we know the volume in one dimension, either radius or height, we can find the other dimension. And that's what we saw again and again today, and that's what we're going to see in our homework today as well. So take a moment to work on your homework, and then let's check that together. Okay, so here's tonight's homework. Another table like we had in class. We have the diameter of the base, the area of the base, height, and the volume. All right, so this is the diameter, which means I'm also going to want to find out what the radius is going to be as well. So I'm going to add another column here just so I can make sure I know what I'm working with. So if the diameter is 4, the radius is going to be half of that, which is 2. The area of the base is pi times the radius squared. So in our case, 2 squared is 4 times pi. And then to find the volume, we're going to multiply those two pieces together, 4 pi times 10, for a total of 40 pi. Alright, and this one, we have a 6 and a 63. I can definitely cut that in half, right, divided by 2. So 6 divided by 2 is 3. For the area of the base, it's pi times the radius squared, which is going to be 9 pi. I'm going to multiply that by some h value in order to get to 63. So 9 times what equals 63? Or you could think about 63 divided by 9 pi, if that helps you out. But knowing your math facts, 9 times 7 equals 63. So that's our height right there. Here, I can go either direction first. If I want to go this way, I can. This way, it's going to be 25 pi times 6, because it's the area of the base times the height. That would be 100, in this case here, 150 pi, 150. And to go back this way, I think about pi times the radius squared. Radius squared. So what number times itself can get you to 25? That's going to be a 5 times 5, or 5 squared, which makes our radius equal to 5. And to go this way, I'm going to multiply by 2. So 5 times 2 is 10. Alright, number 2. A cylinder has a volume of 45 pi and a radius of 3. What is the height? So again, volume equals pi r squared h. They said the volume here is 45 pi. We know that we have a pi on this side, we have a radius of 3, so 3 squared, and we have an h. So 45 pi is equal to 9 pi times h, and the 9 is coming from 3 squared. I could divide both sides by 9 pi. The pi's cancel out. 45 divided by 9 is 5, and so 5 becomes the height of the cylinder. That's all there is to it. Number 3. Number 3 says that there are 3 cylinders that have a volume of 2,826 centimeters squared. Cylinder A has a height of 900, cylinder B has a height of 225, and C has a height of 100. Find the radius of each cylinder and use 3.14 as an approximation for pi. So we're going to need to do basically 3 different math equations here. One for A, one for B, and one for C. Okay, so for A, we're going to start with our volume. Our volume is 2,826 centimeters squared, and that's equal to pi, which is 3.14, times the radius squared, which we don't know, right, r squared, times the height. And for A, the height is 900. 900. So all we did is we took our formula and we had pi r squared h right there. We're putting in the numbers that we do know and setting it equal to the volume that's given in this case, 2,826. So now what I want to do is multiply some things together and get some things separated to find out what r is going to be. Alright, so I went ahead first of all and I just divided both sides by 900 to start with. And 2,826 divided by 900 actually equals 3.14. What a surprise. So that's going to be equal to 3.14 r squared. If I divide both sides by 3.14, then we have 1 equals r squared. So what number times itself gets you to 1? That's going to be 1. So r is equal to 1 for volume for cylinder A. Cylinder B, same idea. We have 2,826 is going to be equal to pi, 3.14, times the radius square, which we don't know, times the height, which in this case was 225. 225. So again, I'm going to divide both sides by 225, and 2,826 divided by 225 is equal to 12.56. That's going to equal 3.14 r squared. Divide both sides by 3.14, 3.14, and that's going to be equal to 4, which equals r squared. So what number times itself gets you to 4? That's going to be 2. So the radius is going to be 2 because 2 squared is 4. And finally the last one here, we have 2,826 equals 3.14 r squared times, and the last one has a height of 100. And again, you could multiply those together first and then divide. It doesn't make any difference to me which one you try to do first. I just keep the same pattern going on here. Okay, so I'm going to divide both sides by 100, which means that this becomes a decimal. 28.26 equals 3.14 r squared. Divide both sides by 3.14, and 28.26 by 3.14 is 9. That equals r squared. So what number times itself gets you to r? That's going to be 3. So the radius in this case is going to be 3. So 3 problems in one. A lot of good practice there working with your division facts and trying to get that all figured out. Okay. Number 4. A gas company's delivery truck has a cylindrical tank that is 14 feet in diameter and 40 feet long. Sketch the tank, mark the radius and the height. Okay, so we have a tank that looks like this. Right, you've maybe seen these on the road somewhere. That's what it looks like, something along those lines. Maybe you just kind of dot a line there, something like that. All right, the diameter says it's 14 feet, so that's going to be this way. 14 feet, and the length is 40 feet long. So there we go, we have the height and the diameter. It wants us to sketch the radius though, so the radius is going to be here, and I can go this way, go across, it's the same, even though it doesn't look round, it is. The radius is going to be 7. So how much gas can fit in a tank? Well, that's going to be the equation. Volume equals pi r squared h, and in our case here we have pi. The radius is 7 squared, and the height, in this case is going to be the length here, is going to be 40. So we have pi times 49 times 40, which is going to be equal to 1,960 pi. Now we could leave it in terms of pi, and that's going to be 1,960 pi, and that's going to be feet cubed. Or you can multiply that out and do 1,960 times 3.14 to get an actual number, and that's going to get you approximately 6,154.40 cubic feet. So if you worked it all the way out, you could, or if your teacher said leave it in terms of pi, you could do that. Both are appropriate answers. It really depends on what they're wanting. In this case, it said how much gas can fit in the tank. So you probably want a full number answer, not in terms of pi. All right, and our last one here, I think it's the last one, maybe not. It says here's a graph that shows the water height of the ocean between September 22nd and September 24th, 2016 in Bodega Bay, California. All right, so here's our graph showing the height of the ocean in a period of a couple days there. So estimate the water height at 12 p.m. on September 22nd. Let's find the right date. Here's September 22nd, here's 12 p.m. and the height is right about there. So how high is it? I look across right about there. This is in feet, and we're about 3, there's 4, or halfway between. So you might say about 3.5 feet is about where that is. How many times was the water height 5 feet? And find the 2 times. Well, here's 5 feet. Where was it? 5 feet. It's going to be every time it crosses that horizontal line. So here, and here, also here, and here. So it was that height 4 times. And in terms of when was it that height, we can look at our time here, and we jot down, we're going to say it's there. So that's going to be sometime after 12. This one's a little before 6 o'clock. So if this is a 6-hour chunk of time, that's probably about 3 o'clock there. So maybe about 2 p.m. on 9/22, and maybe again right before 6 p.m. So maybe 5 p.m. on 9/22. And then we could look over here. It's about halfway through. So that looks like about 3 p.m. on 9/23, and maybe a little bit after, so maybe 7 p.m. on 9/23. Again, that's just approximate. I'm looking on the dot on the graphs. That's exactly where it took place, but that approximate times. What was the lowest the water got during this time period? All right, the lowest we can see in our graph here looks to be somewhere about right here. That seems to be the lowest, right there. Okay, so this low point, even though this looks pretty similar, hard to tell, but we're going to call that the low point. Our low point then, in terms of what was it, in terms of its height, it's up here, and it's a little less than it's a little less than half, so maybe it's about 0.4 feet. If you want to say 0.3, that's okay. And when did it take place? Well, it took place before midnight on the 23rd, which means kind of a trick question here. It's actually going to take place on the 22nd, right? Because it's still a 22nd until it gets to here. So this is all 22nd there. And we might want to say at about 11 p.m. So it's kind of what you know about clocks and times, right? It's before 12 a.m., which makes it 11 p.m. and it's the previous day. All right. Does the water ever reach a height of 6 feet? 6 feet is this horizontal line here. Does the graph ever touch? No, 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 no. We would say no, it does not. And that's it for today. Hope you have a great day, and we'll see you next time.